Welcome back, smart mathematicians. Let's do question 7.2. So in the diagram alongside the graph of f of x is equal to negative 2 sine x is drawn for the interval x element of this domain, where x is from negative 180 degrees to 180 degrees. Write down the period of f of 3x. Okay, write down. So we can straight away write down that the period is 120 degrees. Okay, but now how do we get that 120 degrees? Let me just explain that. We have f of 3x. It means that where there's x, we're going to put 3x. So this is like f of 3x is equal to negative 2 sine 3x. Okay, you see that? So remember the effects of the parameters a, p, k, q. Okay, right, let me just use this. Remember that f of x is equal to a sine kx plus q. Let me just put these three parameters a, k, and q. A, remember, affects the amplitude and the range. And then what about k? Or let me start with q. Q is for the vertical shift, upwards or downwards. And then what about k? K affects the period of the graph. Right, what is the period of this graph, the original graph? The period is 360 degrees. It means that the graph will repeat itself after 360 degrees. The graph will repeat itself after 360 degrees. You can see that from negative 180 degrees it goes, and then that is 180 degrees, and then from 0 to 180 degrees is another 180 degrees. Okay, so you said 180 plus 180, that is 360 degrees. You see that the graph repeats itself after 360 degrees. That's the period of this graph, of the graph of f. Now, k is going to affect the period of the graph. How does it affect? We divide the period of the graph by k. Please remember that. You can treat this as a formula. So period is equal to the 360 divided by k. Not this one varies, isn't it? 360 depends on the graph you're talking about. Now our graph of f of x is having a period of 360 degrees, so that's why I'm having 360 there. It's not 360 for all the graphs. No. Let's say the period of the graph is what? Is 180 degrees. So it means you're going to put what? 180 there. Okay. So now, and then becomes 360 degrees divided by k. Our k is 3. So it's 360 degrees divided by 3, which is 120 degrees. See that? So it means the graph now is repeating itself after every, what? 120 degrees. Like, let me try to sketch this graph. So this is the origin here, and then 90 degrees. The graph is at negative 2. So it means now it's going to be at negative 2 at 30 degrees. We say 90 divided by 3. So we're dividing everything by the k value, 3. So it's going to be here. And then 180 degrees here, we divide 180 by 3 is 60 degrees. So it's here. Okay. And then come this side, negative 90 degrees also is negative 30. At negative 90 is 2. So it's going to be 30 here. Divide negative 90 by 3 is negative 30. And then divide negative 180 by 3, you get negative 60, which is here. Okay, you see that? So the graph will repeat itself after every 120 degrees. See that? Okay. This is here 60, then 60 there. 60 plus 60 is 120 degrees. So the graph will repeat itself after every 180 degrees. If you can extend this graph also, it's going to be like this. Then turns, see that? Okay. And then it goes on like that. Okay. See, After every 120 degrees, it repeats itself. Again, if you say from negative 180 here to negative 100, and this will be negative 30, negative 60. From negative 180 degrees to negative 60 is 120 also, okay? All right, even here we can extend it. Goes on. After every 120 degrees, the graph repeats itself, okay? So that's the period of the graph there. So that's what you're supposed to do anyway. We just asked to write down the period of the graph. This was just enough. The answer there was just enough. We'll meet when you're doing question 7.3.